Welcome. Welcome friends, welcome to my channel APS. This is the fourth episode of previous series questions of JEE Mains and Advanced. Hope you like the video and don't forget to subscribe and click the bell icon for more updates. Hello everyone, APS here. So today we will discuss 5 or 6 problems of current electricity previous series questions. Okay, so let us take the first problem and try to solve this. So what the question says, in the given circuit it is observed that the current I is independent of the value of the resistance R6. Then the resistance value must satisfy. Means it's indirectly mean to say that if there will be no current in R6, then what values of resistance must be satisfied? So you can easily judge this problem by Wheatstone bridge, right? So you can easily judge this problem by Wheatstone bridge. This is R5, I forgot to write. Okay, so for no current to be flown in this circuit, R1 into R4 equals R2 into R3. R1 R4 equals R2 R3, so that no current will flow in this R. So next problem says, in the circuit shown, the circuit P is not equal to R. Okay, the reading of the galvanometer is same with switch S open or closed. Okay, then which condition satisfied? Okay, so as there is no charge in the reading of galvanometer, with switch open or closed, okay, which implies that this bridge, Wheatstone bridge, is balanced. If it is a balanced Wheatstone bridge, then current as in I, current in R equals current in G, and current in P equals current in Q. Okay, once again I am saying, as there is no charge in the reading of the galvanometer, with switch open or closed, means it is independent of this switch, so it makes a Wheatstone bridge which is a balanced Wheatstone bridge. That means the current in R equals the current in G, means it is a balanced Wheatstone bridge, so no current will flow from here, so it can be easily removed. Okay, right? So these two are in series. Once again I am drawing this. We can draw this circuit like this. Okay, sorry, the writing is not good. This one is G R. Once again the circuit can be drawn like this. Okay, we just remove this wire. So see, these two P and Q are in series and R and G are in series. So we know that in series the current remains same. So current in P equals current in Q and current in R equals current in G. So which option matches match our concepts? IR equals IG, IR equals IG. So option A will be the correct answer. Okay, so let us take the next problem and try to discuss that. Okay, so the next problem says, in the below circuit the current in each resistance, means we have to find the current in each resistance. So how do we do this? Okay, now see, the potential difference across each resistor is 0. Here is also 2 volt, here is also 2 volt, 2 volt, 2 volt, 2 volt, 2 volt. So the potential difference across each resistor is 0. That means V equals 0, and we know V equals IR from Ohm's law. So I equals V by R. So the value of V is 0 and the resistance will be 1, so it gives 0. So option C will be the correct answer. Okay, so let us try to discuss more problems. So the next problem says, find the equivalent resistance between A and B. find the equivalent resistance between point A and B. So how do we do this problem? Okay, so we will assume something. Let us assume that the potential at this point is X. So this at this point it will also be X. Okay, so now let us redraw this circuit. How can we do? How can we do this? Now this point is A, B, and let this point be X. That means this point. Okay, so let us rewrite all the circuit, all the resistance between these points. Means this, there is only R between X and B. There is only R between, we are now considering only R between X and B. That means we'll draw this here. Okay, so we have drawn the first circuit. Now between A and B, 1, between A and B, between A and B. Now between A and X, R. Now between X and B, between X and B one more is there, so connected parallelly, and in between A and X one more is there. Okay, A and X, so these are connected in parallel. R, this R and R. Now if we'll solve this, we get A, X, B. So this R and this R is in parallel, so for a parallel circuit, R equivalent equals R into R by 2R. So the answer will be R by 2. Same case applies here. R equivalent is R by 2. Okay, so now here is only R. Now R by 2 and R by 2 is in series. See this R by 2 and this R by 2 is in series, so again we can write like this. So R by 2 in series, we know we can easily add this, so it comes out to be R. Now this R and this R is in parallel, this R and this R is in parallel, so for again for a parallel circuit, R into R by 2 R, so R and R gets cancelled out, so our final answer will be R by 2. So let us take the next problem and try to solve those. Okay, so the next problem says find the equivalent resistance between A and B. So this point is A, I'm sorry I forgot to write, this point is A, so find the equivalent resistance between the point A and B, and these are the resistors. Resistor having resistance R. So how do we do this? So let us assume the potential at this junction be X. So all are in series, all are in parallel. Okay, so we know that in parallel the potential remains the same. In parallel the potential remains the same. So here, so at this this B, okay, so here it will also be B, here it will also be B, and here it will also be B. Why? Because in the parallel circuit the potential remains the same. Okay, so let us again simplify this. So for simplifying this, we will draw like this. This is point A, this is point X, and this is point B. So we can easily see that between the point A and X there is only one resistor R with resistance R. Okay, so only one, and in between the point X and B, there are three resistance, X and B1, X and B2, X and B3. So there will be three resistance, that is 1, all are connected in parallelly. Okay, so this r and r. Now we'll solve this, and while we are solving this, 1 by r equivalent equals 1 by r equivalent equals 1 by r plus 1 by r plus 1 by r, that is 3 by r. 1 by r equivalent, so r equivalent tends to r by 3 for this circuit. Okay, so now again r equivalent equals r plus r by 3, that is 3r plus r, that is 4r by 3 is the correct answer. First we simplify this, so we get r by 3. Now r by 3 and r is in series, so we just add this and we get the answer as 4r by 3. Thank you for watching the video. If you really like the video, then please do hit like, share and subscribe. Thank you.